Hello everyone, this is Kishola Ghosh, uh, and today I'm going to show you a project that I've built. Uh, this is called the Tic Tac Toe game. I had built this short project in my first year. So here in first year I had built it with the C program. Means I had only implemented the game through uh, basic programming. So here is the code. As you can see, I can show you the code. It is my GitHub repository. You can check it out. So here is the code that I've written for the uh, uh, game. So if I run this program, uh, if I copy this code uh, here, and I'm showing it to you, I'm showing it to you using an online compiler, a GDB compiler. Yeah, GDB online compiler. So yeah, if I do, I paste it here. Yeah. If I run this code, you can see here's the output window. Yeah. Here player 1 and player 2 are there. Player 1 has a symbol X and player 2 has a symbol 0. You can assume player 1 is you and player 0 or player 2 is the computer. Here you can choose like any. Here ABCD denotes the positions of the matrix or table. You can choose any positions like AA has a coordinate of 1 1 and B has a coordinate of 1 2, where these first number denotes the row number and second number denotes the column number. So if I want to insert my symbol at position G or uh, 2 3, uh, I'm doing that like so like G. Yeah, so it is inserted at G. As you can see, it is X there. Next, I would like to insert at N. Yeah. Um, as you can see, at position N, uh, 0 has been inserted, or player 2 has inserted it. Well, here, player 1 and player 2 are me only. So you can go on playing this game until entire rows value and the entire columns value or entire diagonals value matches. If it matches, you win or the opponent win. So this was using a C program. Uh, I did the same by using HTML, CSS, JavaScript, and the main thing I used is the min-max algorithm, which I learned through my course. Uh, you can see the GitHub repository. Here you can see the JavaScript files and the HTML files required for this game. So I had hosted it on GitHub pages. Let me run this site again. Yeah. So here, this is a user interface that I've created using CSS and JavaScript. So I'll I insert it here. Computer insets at this position, maybe. Yeah, computer one. As you can see. Uh, Let me try another feature called computer play first. Means the computer inserts in the board first. Then I insert here. Then here the computer one. Maybe I want to reset the entire board. I'd also kept a reset button. So reset means the entire board will be clear and you can play again. Yeah. This is implemented using algorithm using AI called the min-max algorithm. It is a adversarial search technique. Means there will be two competitors, and each competitor will try to increase their utility value or the chances to win. You can also call the utility as a heuristic, means how far you are away from your goal state. Uh, Here, for example, if the computer's goal will always be to minimize its utility, its or heuristic function, and maximize the heuristic function of the opponent, or to uh, or here maximizing means that make the opponent farther away from the goal state, which in turn means you will win. So let me show you the working of the algorithm. Yeah, I've taken this image from site, as you can see here written blog dash c7ff.com. So here's a tree built upon this grid. The first step, as you can see, is the initial step, and these steps are the subsequent steps. Uh, yeah, uh, Here it's max min written, means I want to maximize my probability. Here X is the player. Uh, it can be computer or me. Let's say it's computer. The computer wants to maximize its chances of winning and uh, minimize the chances of winning for the opponent. It's O denoting the other player. Similarly, we go on searching. Like in the first step, like we insert X at some position, random position. We show every step possible to insert X. There will be, as there are 9 grids, so there will be 9 possible uh, ways to insert X. And then for each possible way, minimized way, we find the maximum for our steps. Means if X is inserted in the position 1, 1, as you can see here, uh, in the third layer, X is in the 1, 1, and we insert 0 at position 2, what will be the utility? And if we insert 0 in the position 1, 3, what will be the utility? And similarly, it goes on. This entire tree is built by the computer to analyze what will be the next step that can be performed by the user. This helps to track the entire uh, uh, path that the opponent can take, assuming that the opponent is optimal. Here, in this algorithm, it is assumed that the opponent is optimal. Uh, so it assumes that the opponent will play uh, uh, without any error. But in real life, it is not true. It is a plus point for the computer. Uh, it tracks what path has the least utility function, or what path is the lowest, or takes the lowest time to win. Uh, Here we can see, yeah, this entire tree is constructed, and here backtracking is also possible. So this entire tree is built. Mm, that's all. You can learn more about the adversarial search technique. I used a video from YouTube to learn about this technique, adversarial search, the theory based upon it. I will provide you the link in my GitHub repository. You can uh, see that. Uh, I will try to implement uh, this using the alpha beta pruning also. The alpha beta pruning means we do not have to draw the entire tree, but we can prune some of the branches in the tree uh, by some predetermined technique. Mm, I will try to implement that. This will significantly reduce the time complexity. Uh, so that's all. Thank you.